Good morning. This is the second module on acoustic phonetics, module 11, which is titled Larynx as the Source of Sound, Physical Properties of Voice. Very briefly, towards the end of the first module, we had mentioned the source filter theory of speech production. And this source filter theory is the acoustic theory of speech production. And in this, very briefly, we had mentioned that a source is a larynx. And we would like to understand through the present unit what exactly is the source and what are the physical properties of voice as produced by our vocal activities, vocal cord vibrations and laryngeal activities. Now, just a brief recapitulation of production of voice, because that has a lot to do with what kind of acoustic transmission will take place. In the production of voice, in some of the earlier units, you must have learned about the aerodynamics of voice and Bernoulli's effect, which is the phonation process, and periodic opening and closing of glottis for the release of air, which is thus phonated, and then frequency of vibration of vocal cords, which is the fundamental tone. Now, just as an overview of the same, I would like to remind you of what is this aerodynamics of voice production. Please take a look at the slide before you, which shows some kind of a continuous chamber with a break in between, and that break represents the vocal folds. There is a subglottal chamber and supraglottal chamber, and what we want to show through these series of pictures is that as the airstream travels from trachea to the subglottal chamber, if the glottis is closed because the arytenoid cartilages have done something, they are holding the vocal cords tightly closed, and therefore there is tension in the vocal cords, because vocal cords are meant to be very thin, highly elastic structures. So you stretch them and you hold them tight in order to close the glottis. As a result of that, as the airstream comes, as the airstream tries to pass through the glottis, the air pressure builds in the lower chamber. If the glottis is closed, the air pressure will continue to build up. And as a result of that, because the air pressure in the subglottal and the supraglottal chamber is unequal, therefore, as a result of the so-called Bernoulli's effect, there is an effort to equalize the air pressure. And that equalization happens when the air pressure forces open the glottis. So that kind of force opening of glottis leads to equalization of air pressure in the subglottal and the supraglottal air chamber. As soon as there is airflow, the air pressure is released, the vocal cords again, because there is tension in the vocal cords, they are stretched, so again they will come back to the closed position. So this is how, once the arytenoid cartilages have stretched the vocal cords, produced a certain amount of tension, then every time the air pressure builds in the subglottal air chamber, there is likely to be the Bernoulli's effect taking place, and therefore the vocal cords open and close, the glottis is forced open and then it closes again due to the normalization of the air pressure across chambers. And this whole phenomenon, this whole process is the aerodynamics of voice production. So this was basically a reminder of what you must have learned already in articulatory phonetics. We are concerned with the number of times vocal cords opening and closing, and that frequency of vibration of the vocal cords leading to the so-called fundamental tone. And that fundamental tone is the voice is the most important characteristic of voice, most important acoustic feature of voice. Okay. Now, this fundamental tone, the frequency of vibration of vocal cords obviously varies with the nature of the individual laryngeal structure, and individual laryngeal structure could be, vocal cords could be large or small or heavy, bigger mass or lesser, or lighter in weight, and so on. The structure may be very different. So fundamental frequency, the frequency of vibration of vocal cords, it varies a great deal, varies as per individual laryngeal structure, because the individual vocal cords may be, light in weight or heavy or longer or shorter in length, or, depending on that, they may vibrate slowly or they may vibrate faster, and that also varies with age. With young children, they are very small and light vocal cords, so they are likely to produce high frequency sounds, and men with large size vocal cords with heavier mass, their vibrations may be slower. So F0 varies with individual laryngeal structure, and it varies with age, it also varies with gender. Now, apart from these kinds of characteristics, which are kind of, genetically predetermined, I mean, you are born with a certain laryngeal structure and therefore you have a certain kind of a voice. But apart from that, the social, the cultural, and the linguistic exposure and the training that you undergo for, language or music or learning new languages or voice modulation or any kind of diction, all of that leads to modifying your vocal cord vibration. So this is what you actually do. That's part of nurture. The first part was the individual structure which you are born with, that is the nature. So emotional states of the speaker, again, that could be very individual and very context specific and situation specific. So these are external factors which are part of the environment inputs, or part of the environment, part of the nurture. And age and gender and the individual laryngeal structure that you are born with, all of this is genetically predetermined. So there is something called nature and nurture contributing to the individual voice. How individual voice is distinct and different from the other voices. Where we talk about nature, properties of larynx and vocal cords, mass, length and elasticity of vocal cords, age-related changes therein, gender-related changes, and then tension in the vocal cords, which may be a volitional activity, it may be voluntary. If you want to produce a high-pitched voice, if you are a singer and you want to take your voice to a higher pitch, you will increase the tension in the vocal cords so that it reaches a certain kind of level of pitch. So all of these things, these are kind of natural properties of larynx and vocal cords, but tension in the vocal cords, the range within which tension can be created, that is very, very individual. So this is part of nature, but what is acquired from the environment is nurture. So fundamental tone of voice can vary as per all of these factors, some part of nature and some part of nurture. Then F0 or fundamental tone is perceived by the hearer as pitch of voice. So pitch is a new term that we are introducing, but pitch, as in, we'll cover the details of how voice is heard in terms of pitch and loudness and quality in module 13. For the time being, we would like to understand F0 and the nature and the nurture properties of F0. Now, fundamental tone is not just a single tone which is entering the oropharyngeal chamber as part of speech production exercise. It is accompanied by a whole number multiples of frequencies called overtones or harmonics. All these harmonics are whole number multiples of F0. If somebody is speaking with a fundamental tone of, let's say, 100 hertz, a male voice's average is generally around 100. It could be anything from 70 to 120, 130, 40. So within that range, if the average is about 100, then the whole number multiples of it, the harmonics will be 200, 300, 400, 500, 600. So that those multiples will be produced along with the fundamental tone. And these overtones or harmonics will obviously, the first one, the fundamental tone, will have the highest energy, highest amount of energy, so therefore the highest amplitude. The energy consumption leads to the second harmonic with a little less of amplitude, the third one a little less and less and less. Subsequent harmonics will have lesser amplitude because of the lesser amount of energy. Now here is a picture. This is an image which shows spectrum, frequency on x-axis, amplitude on y-axis, and it has F0 plus overtones, which are the whole number multiples of F0. In between there are certain peaks which shows that the entire glottal tone must have passed through some kind of an air column causing some kind of resonance. So these are peaks which show these are spectral peaks which show resonances. Otherwise, from the first one at 10 decibels, you can see the last one is going down to something like much lower, about minus 20 dB or something. So you can take a look at that figure, and we'll have more of spectra of voices. Now here is a diagrammatic representation showing these three figures. The first one, the lines are drawn too close, showing lower frequency of vibration as fundamental tone, and therefore the whole number multiples are maybe 100, 200, 300, 400. But in case of a female voice, if the first frequency is higher, it could be anything like 180 to 230 or something. So 200 is the average, then 200, 400, 600, 800, those will be the harmonics. For a child, perhaps the fundamental tone could be 300 hertz, and then the overtones will be multiples of 300. Now, the glottal tone consisting of the fundamental tone and harmonics enters the oropharyngeal chamber, and then the oropharyngeal chamber, which is a continuous air column which begins to show resonances modifying the voice. So oropharyngeal chamber acts as an acoustic filter, as a selective resonator, amplifying some frequencies. So there is resonance. No amplification means those frequencies will be filtered out. Now this leads to resonant frequencies called formants, which we will discuss in detail in the module 12 in the following module. For the time being, we will focus on F0 as pitch, but F0 perceived as pitch of voice. In fact, the voice is also heard as loud or soft or musical or non-musical or good quality or a little jarring quality, depending on the physical properties of the voice thus produced. This is being dealt with in detail in module 13. Then before we conclude this unit, I would also like to mention here that F0 or fundamental tone can vary. It can vary across a segment which could be just a vowel, not a sentence or a word, a vowel. So with a vowel, within a vowel, if the fundamental tone, let's say, starts at a certain level and then falls down to a lower level, It could be something called, falling pitch. If it begins at a level and goes higher, it could be rising pitch. It could be falling rising, it could be rising falling, also with a contour on, of F0 variation across the, duration of the vowel. And if any of these tones, tonal contours or levels, if any of these have a linguistic function, then they are called as tones. They are tonemes, like phonemes, they are tones as phonemic, they can be phonemic in a language. Kar and kar become two separate words, two distinct words in Punjabi language. Karna, to do, kar, and kar is home or house. So therefore, this falling tone in kar is phonemic. These are the minimal pairs that I'm talking about. So it becomes tone, and tone as a phonemic function means that is the linguistic function of F0. Now similarly, if this F0 varies across the different segments of a sentence, rising at the end, falling at the end, or with a straight kind of a thing, rising somewhere in the middle, this could also have a linguistic function. For example, interrogation. Are you going there? It could have a rising pitch. Rising pitch, rising F0 at the end of a sentence could be interrogation. Falling pitch at the end of a sentence could be a statement, or a question word in the middle, like a Hindi sentence, तुम कितने बजे आ रहे हो? तो कितने बजे, getting the maximum pitch, could be, rising in the middle and then coming down. This could also be a question type of a question of a different type. So these are the linguistic functions of F0. In acoustic phonetics, right now we are not dealing with the linguistic functions, that would be covered in phonology. But for the time being, F0 is the most important property of acoustic property of sorry of voice. The fundamental tone and the harmonics, as I mentioned earlier, they enter the supraglottal chamber, the oropharyngeal chamber, and then lead to various modifications through that filter process, or producing, ferments, or producing noises, or through various mechanisms. We will discuss those in the following units. Thank you very much.